Yes, as long as you've taken care of your 2-6 worksheet, that's fine. Okay, so now here we go. We're going to start section 2-7. 2-7 is an continuation of 2-6, except for it's going to be with slant asymptotes, okay? Now, the first thing you need to understand is the slant asymptote is exactly what it says. Slant means mx plus b, correct? So if you have a line, it's mx plus b. A slant asymptote, when the degree n of x is exactly 1 unit larger than the degree m of the d of x after you have reduced the function completely. Okay? So you will have a slant asymptote when the degree of your numerator is exactly 1 unit larger than the degree of the denominator after you have reduced your function completely. Okay? How do you find a slant asymptote? You find a slant asymptote by doing long division, and then the slant asymptote is that without the remainder. So you have no remainder. So it's y is equal to this without a remainder. Okay? An example. Does this have a slant asymptote? So the very first thing you're going to do is you are going to simplify both the top and the bottom. Can I factor the numerator? No. Can I factor the denominator? Can I factor x squared plus 4? No, I cannot. I cannot factor that into 2 binomials. So that means that this is as far as it can go. So n is going to be 3, which is the degree of the numerator. M is going to be 2, which is the degree of the denominator. And now you're going to tell me, what is the relationship between n and m? Is n less than, greater than, or equal to m? N is greater than m by exactly 1 unit. Since it is greater than m by exactly 1 unit, we have a slant asymptote. How do we find the slant asymptote? You're going to do long division. That means you're going to put the x squared plus 4 on the outside, and on the inside you're going to have a 2x cubed plus a 0x squared plus x minus 3. Yes? So, what do I multiply x squared by to obtain a 2x cubed? You're going to multiply by a 2x. So, you're going to multiply on the diagonal. 2x times x squared is going to be a 2x cubed. 2x times a 4 is going to be an 8x. When you do long division, what do you do after that? You change the sign, so that becomes a minus 2x cubed and a minus 8x. And those cancel out to give me a negative 7x minus 3. Negative 7x minus 3. Is there anything I can multiply x squared by to obtain that? No. Here's what I need you to do immediately. I want you to simply cross this off because that's your remainder. You don't need it when you do your long division to find your slant. Your slant asymptote will be y is equal to just 2x. Meaning, when you graph your slant asymptote, you're going to start at 0, 0, and you're going to go up 2 units and to the right 1, and then connect it with a dotted line, and that is your slant asymptote. Do we all understand what I just said? You're going to graph it just like you did y equals mx plus b. Okay? Next, does this have a slant asymptote? Well, you're going to immediately say the degree of the numerator is 3. The degree of the denominator is going to be 5, which means n is less than m. And according to our rules that we learned on Friday, when n is less than m, this means that you have a horizontal asymptote at y is equal to 0. Do we all understand that? Now here's what your brain needs to grasp. You either have a horizontal asymptote or a slant asymptote. You cannot have both. I repeat, you either have a slant or a horizontal. You may not have both of them. You may have verticals with both of them, but you may not have both a horizontal and a slant. Do we all understand that, yes or no? Okay, now, the next thing is talking about all the lovely little things that I want you to do to be able to graph a rational function. So exactly what we did yesterday. Yesterday or on Friday, we went ahead and we found the domain of the function. Finding the domain of the function gives us all the holes in the graph, yes? All the values that x does not have a corresponding y value to. Then step 2 is we simplify the function to find the vertical asymptotes, right? The vertical asymptotes came from the denominator, which had the domain restrictions. Then we find the horizontal asymptotes by looking at the degree of the numerator, the degree in the denominator. Then we're going to find the slant asymptotes if it exists. And then number 5, you're going to plot all your asymptotes with dashed lines. Number 6 is you're going to find and plot the y-intercept. What is a y-intercept? The point on the graph where it crosses the y-axis. If it's crossing the y-axis, what can you tell me about x? That it's 0, yes? You're going to let x equal 0 and solve for y. And then step 7, find and plot the zeros of the reduced n of x. Okay? How do I find an x-intercept? An x-intercept is the point on the graph where it crosses the x-axis, implying that y is 0. Do we all understand that? Now, number 8, plot points between all of the above to finish off the graph. So this is exactly how you're going to do tonight's homework. And if I were you, I would check tonight's homework to see if maybe I've done any homework problems in class. So here we go. Example 1. This is how you will do tonight's homework, step by step. Yes? This is exactly how you do tonight's homework. And as I said, I would really check over tonight's homework to see if I did any of those problems in class with you. Are you ready? Okay, keeps you awake. First things first, domain. Domain means you're going to take d of x, which is the original denominator, and set that not equal to 0. d of x is going to be x squared minus x minus 2 does not equal 0. Can I factor x squared minus x minus 2? Yes, that's going to give me an x minus a 2 times an x plus 1, and that cannot be 0. So x cannot be 2, and x cannot be negative 1. Those are my domain restrictions. Do we all understand that? So how do I write that? X is an element of the reals such that x cannot be 2 or negative 1. Do we understand that, yes or no? We good? The next thing is going to be vertical asymptotes, okay? How do I find vertical asymptotes? Well, how do I know if I even have a vertical asymptote? Where do my vertical asymptotes come from? This is what we did last week. They come from your domain restrictions. So since I have 2 domain restrictions, I have the potential for 2 vertical asymptotes. Do we all understand that? So how do I know that? I have to come up here and I have to reduce this function if at all possible. So I have an x minus 2 times an x plus 1. Does anything cancel out that is both in the top and in the bottom? No. Ladies and gentlemen, this right here is your reduced function, meaning nothing cancels out. Do we all understand that? So my vertical asymptotes come from the reduced f of x, or the reduced d of x, settling them equal to 0. So x plus 2 is equal to 0, and x minus 1 is equal to 0. So my vertical asymptote is that x equals negative 2, and x equals positive 1. Do we understand what I've done so far? The domain and the vertical asymptotes. Okay, the next thing I want to do is a horizontal asymptote. Well, how do I know if I have a horizontal asymptote? Horizontal asymptotes are found by comparing the degree of the numerator, which is going to be 1, with the degree of the denominator, which is going to be 2. So n is 1 and m is 2. What is the relationship between n and m? Aw, schnookies. Yep, thanks. Good catch. I wrote down the wrong thing. So this is x minus 2 and x plus 1. I simply wrote down the wrong thing. I should have looked up and confirmed, and I did not. Thank you. Okay, Does everybody understand that the degree of the numerator is 1 and the degree of the denominator is 2? Thank you so much for checking that. What is the relationship between n and m? N is less than m. So since n is less than m, what is my horizontal asymptote going to be? It is going to be y equals 0. So I have y is equal to 0 as my horizontal. What does that imply my slant will be? And what did I say before? You can't have both a horizontal and a slant. So since I know I have a horizontal, what does my slant have to be? None. 0 is a number, so say none. Do we all understand what I've done so far? So on tonight's homework, it literally says A, domain, B, vertical, C, horizontal asymptotes, and D, slant asymptotes. Do we all understand what I've done so far? Okay, so I'm going to come over here, and I'm going to plot all of that stuff. So I need to first plot my vertical asymptotes. What's my vertical asymptotes? So I'm going to plot a vertical asymptote at 2 and at -1. Do we all see that, yes or no? Okay. Now, do I have a horizontal? I do. What is my horizontal? Now, listen. When I have a horizontal asymptote going through 2 vertical asymptotes, what usually happens is it stops at the first asymptote that's vertical and picks up again at the last asymptote and going all the way across. Meaning I have a break in my horizontal asymptote. Do we all understand that? How do you know that for certain? When in doubt, graph it out. Do we all understand that? So I know what my asymptotes look like. Now what I'm going to do is I'm going to come back over here and I need to go ahead and I need to do the next steps that I have in here. So I have done all of this so far and I plotted them. So what's it say to do next? Find your y-intercepts. So I'm going to come over here and I'm going to find my y-intercept. So my y-intercept is found by letting what? You're going to let x equal 0. So my equation that I have here is going to be y is equal to 3 times 0 over 0 squared minus 0 minus 2. Do you see that? What's 3 times 0? So what's 0 times anything? So that means I have y is equal to 0. So I have the ordered pair 0, 0. Now, when I have this, I have the point 0, 0. That's not only the y-intercept, but it's also going to be the x-intercept. So that's what I need your brain to understand. The x-intercept is also going to be the point 0, 0. I already found it, so there's no reason for me to do it again. Do we get that? Because in order for me to find my y-intercept, I'm letting x equal 0. When I found my y-intercept, it turned out that y was also 0. Right here in red. You with me? Now, if it confuses you, well, go right ahead and find your x-intercept. Your x-intercept is whenever you let y be 0, right? So to find your x-intercept, that's going to be 0 is equal to 3x over x squared minus x minus 2. If you put this over 1 and cross multiply, 0 times that denominator just turns into what? So I have 0 equals 3x. If I divide by 3, I have 0 is equal to x. So I'm proving to you that that's going to be the point 0, 0 anyway. Did you have to do that work? No. You should have automatically understood when you were right here. Does that make sense? Okay. All right. So I found my x-intercept. I found my y-intercept. Okay? So I'm going to come over here and I'm going to plot that point. I'm going to plot the point 0, 0. There it is. Do we all understand that? Now, you are going to come over to your graphing calculator, which everybody should have already gotten whenever they came in here today. You didn't bring it with you. So 3x over x squared minus x, is it plus 2? Minus 2? I hit enter, and this is my graph. Do we all see that? It looks a little funky, doesn't it? Okay? Now you got to put it upside down on its buttons. You trying to break my calculator buttons? That's a really shady response. I don't like that response. You didn't want dust to collect on it. Okay, now, does everybody see that's my graph? Now I want you to simply hit Control T. I want you to simply hit Control T. What you want to do is pull out all the x values that are really easy to graph. So what are some really easy x and y values to graph here? I want all the values that are going to be to the left of my vertical asymptotes. So what's my smallest vertical asymptote? Look at your paper, guys. You wrote it. What's your vertical asymptotes? 2 and -1. So your smaller asymptote is going to be -1. So I need to go to the left of -1. So here's -1 right here. -1 goes to undefined. That undefined means that it is indeed an asymptote. So I would want to graph the point -2, -1.5. So write that down. I'm going to write mine down over here on the board. So I would choose to graph, what did I say, -2, -1.5. Then I would probably choose to graph, oh, some of them are not very good, are they? Nope, those aren't very nice numbers, so it kind of gets harder to graph them. So I would probably choose -4 and -2/3. Do we see that? -4 and -0.666666 repeating as 2/3, yes? All right, and then I would go to the right of -1. To the right of -1, I have 0, 0. How about 1 and -1.5? That looks like a good one. Then I have another vertical asymptote at 2, so now I'm going to find more values. I can graph 3 and then probably 2.25. That looks pretty good. And the rest of them probably not as nice. So let's go back over to our graph and let's graph those. We know what they're supposed to look like. Maybe. So I'm going to put these in here. So that's -2, -1.5, -4, -2/3, 1 and -1.5, 3 and 2.25. So if I graph those really fast, that's going to be -2 and then -1.5. That's going to be -4 and -2/3. So what happens here is I'm going to come really close to both of those. And there's my first part of the graph. So then I'm going to go to the next one, which is 0, 0. And then I'm going to do 1 and -1.5. That's going to put me here. And it's going to look like that, going up toward the asymptote. Then I'm going to graph the next section, which is going to be 3 and 2.24, or 2.25, sorry. And the same thing is going to happen there. Do we all see that graph, yes or no? I would probably grab another point over here so that I have another point there. So it might not be a very nice one, but let's go see if we can find one. Probably 4 and then 1.2. So 4 and 1.2 I would grab. So 4 and 1.2. That just gives you another reference point on there. Do we all understand that, yes or no? Questions? Okay, let's do it again. Next one, what do I do first? Domain. So domain is found. By taking the original d of x and setting it not equal to 0. So that's going to be an x plus 4 times an x minus 3, and that is not equal to 0. I went ahead and I factored immediately in my head, yes? So x cannot be negative 4 and positive 3. X is an element of the reals, and it cannot be those values. Do we all understand that, yes or no? Vertical asymptotes. Vertical asymptotes means I'm going to reduce this. The 5 parenthesis x plus 4 stays. I factor this into x plus 4 times x minus 3. Is there anything that is both the top and the bottom? The x plus 4 goes away, and I'm left with 5 over an x minus 3. This is the reduced form that I'm going to use. Do we understand that? So now, I'm going to take the reduced d of x and set that equal to 0. So that means x minus 3 is equal to 0, so x is equal to positive 3. Okay, what does that imply? That this is my vertical asymptote. I only have one. Do I still have a domain restriction in the other spot of 4? I do. It's just not going to be an asymptote. Do we all understand that? Yes or no? Okay. So what do I look for next? Horizontal asymptotes. So how do I find my horizontal? You can go from the reduced if you want to. So if I go from the reduced, I have a degree of what? 0 with a degree of 1. So n is less than m. So what is my horizontal? Y equals 0. So next is going to be my slant. Do I have a slant asymptote? Why? I already have a horizontal asymptote, so I can't have a slant. Any questions so far? So I'm going to graph my asymptotes. And what are my asymptotes? Nope. What's my vertical asymptote? My vertical asymptote is at 3 and only 3. What's my horizontal asymptote? 0. Now, guys, listen up. If you want to put your your horizontal asymptote when it is y equals 0, just slightly above it, the x-axis, so that you can tell that that's an asymptote, you can do that. Do we all understand that? I'm sorry. It does not stop because how many asymptotes do I have that are vertical? Only one, so it's not split. Do we all understand that? Good question. Okay, are we good on that? Okay, so now what do? I need to go find my intercepts now, don't I? So how do I find my x-intercepts? My x-intercept means I'm going to go ahead and I'm going to take n of x and set it equal to 0. But I want reduced n of x because it makes my life so much easier. That's a line. So I'm going to take my reduced n of x and set it equal to 0. So that is going to be 5 is equal to 0. When is 5 ever equal to 0? Never. So am I going to have a reduced one there? Yes or no? No, I won't have one. Do we all understand that? Okay, so that's not true, so I don't have one of those. And the reason why I don't have one of those is why? I have an asymptote, right? So since I have a horizontal asymptote being the x-axis, am I ever going to have any x-intercepts? No. Does that make sense, everybody? Okay, so now find your y-intercept. Your y-intercept is found by what? Sure. So I'm going to take my reduced f of x function. So that's going to be y is equal to 5 over x minus 3. So y is equal to 5 over 0 minus 3 to give me 5 over negative 3. So that means I'm going to have the points 0, negative 1, and 2/3. Yes? Okay, so what do you think I should do now? I'm going to go graph this, right? So I'm graphing the point 0, -1, and 2/3. That puts me about right there. What do you think this graph is going to look like? It goes in opposite diagonal quadrants. Do we understand that? So you already have a point in the bottom left quadrant, yes? So you're going to have a graph in the bottom left quadrant and the top right quadrant. Do we all understand that? Quadrant 1 and 3 are where your graphs are going to be. So we're going to go ahead and we're going to go to our graphing calculator. And I'm going to graph this, and my function is going to be 5 parentheses x plus 4. Denominator is x squared. Anybody help me out there? Isn't it plus x? Thank you. And hit enter. And this is what you have. Now what should you do from here? Control T, right? And I need to go to the left and to the right of my vertical asymptotes. My vertical asymptote in this problem is going to be what? 3, correct? So I need to go to the left of 3 and to the right of 3. So I'm going to go all the way to the left of 3. Now, keep in mind that at -4, it is undefined. It's a hole in the graph there. So you need to add that point there so that you have a nice little jump in that graph, yes? Okay? So I'm going to look for some spots that's really easy for me to graph. And whenever I come down through here, I see that -1, -1.25 is easy. -2, -1 is easy. 1, -2.5. 2, -5. Then I have the other side that I have to go down through. That's going to be 4, 5, 6, 1 and 2/3, 7 and 1.25, 8, 1. Do we see that? So I'm going to come over to my graph, and I'm going to start graphing those points. So -4 is undefined. So at -4, you want to put the undefined. Well, we know it's going to be undefined because that's going to be on the x-axis. Do we all understand that? So we know we're going to have an undefined point there. But wherever it gets close to, you have to make sure that the hole in the graph is there. Then you're going to have -1 and -1.25. -2, -1, 1 and 2.5 negative. Okay, so I'm going to graph those points. This is going to be 2 and -5. 1 and 2.5. -2 and -1. So do we all see this right here? But do you see this hole in the graph? I have to drop that hole in the graph right down there. Do we see that? Yes? There's going to be a hole in the graph right there. Then I'm going to do the other side. The other side is going to be 4, 5, 6, and 1 and 2/3, 7, and 1.25, and 8, and 1, and there's your graph. Candy bars? Do we understand this? I graphed below this right here. Okay, so then you're going to graph the 4, the 5, the 6, and the 1 and 2/3, the 7, and the 1.25, and the 8, and the 1. Those are the other ones. Do you see? Here is the -4. Yeah, where do I want to show you that? I better show you. Wherever it crosses at -4, you want to have a hole in the graph at it. Yep, that's why that big circle is there. Okay? Do we understand that, yes or no? Okay, let's do another one. Are we paying attention? Okay, next. Okay, what do I do first? Domain. Domain, x minus 2. I'm going to take my d of x. It cannot be 0, so x minus 2 cannot be 0, so x cannot be the value 2. That is an elm of the reals, and that is my domain restriction. What do I do next? If that's not working, there's an electric one over there. Vertical asymptote. It doesn't matter. You can do bar or comma or colon. Okay? Vertical asymptotes. Can I factor the numerator 2x squared minus 5x plus 5? No, it's not factorable, which means nothing's going to cancel out. So that means this right here is the entire reduced form. Do we all understand that? So with that being said, if I take the reduced d of x and set that equal to 0, x minus 2 is equal to 0, so x is equal to 2. Not only do I have a hole in the graph at negative 2, but it's actually going to be an asymptote. Do we all understand that? Now what do? I need to find my horizontal asymptote. Horizontal asymptote says that I need to go ahead and look at my degree of my numerator, which is going to be 2, and my degree of my denominator, which is 1, and n is greater than m. So do I have a horizontal? No. Slant. Do I have a slant? Yes. Why do I have a slant? Because it is greater than 1 by 1 unit. So since it is greater by 1 unit, I have to do long division, correct? So I'm going to put the x minus 2 on the outside, and I'm going to put 2x squared minus 5x plus 5 on the inside. What do I multiply x by to get a 2x squared? A 2x. Multiply on the diagonal, that's a 2x squared minus a 4x. And change the signs. Those cancel out, and I get negative x plus 5. What do I multiply x by to get a negative x? A negative 1. So that's going to give me a negative x plus a 2. Change the signs. And that's going to give me, that's a negative 2. So that's going to give me a 3. Do I care about that remainder? No, I do not. Cross that off. So I have y is equal to 2x minus 1 as my slant. Do we understand that, yes or no? Okay, so I'm going to come over here and I'm going to graph. What's the very first thing I'm going to graph? My vertical asymptote. What is my vertical asymptote? I'm sorry? It is going to be at 2. There's my vertical. Now what do? I have to graph my slant. My slant asymptote is going to be y is equal to 2x minus 1. So how do I graph y equals 2x minus 1? Start at negative 1, go up 2 to the right 1, up 2 to the right 1, up 2 to the right 1, and that is going to be my slant asymptote. Do we all see that? And I'm just going to erase those points off of there because it makes it prettier to not have those points. Okay? Now, I'm going to go back and I have to do my points now. So I have to find my x-intercept and my y-intercept. So how do I find my x-intercept? My x-intercept, I'm going to take my numerator and set it equal to 0. So that was 2x squared. But we said we couldn't factor that, could we? So am I going to find any real roots on that? No, so those are going to be imaginary, so therefore this means no, none real. Okay? Do we all understand that? Your y-intercept, you're just going to plug in 0. Yes? Go ahead and finish this for homework. Tonight's homework is this right here. I forgot to pass it out. Nice try. Here's tonight's homework. Fix it. Graphs are on there, guys. Do everything I did today in class. Have a great day, guys. See you tomorrow. I will answer any questions you have tomorrow.